So we'll start the chapter number 10, that is the sound chapter. Okay, we'll start the chapter number 10, that is the sound chapter. So in this particular chapter we will discuss some of the that means longitudinal, what is the longitudinal sound wave, what is the transverse sound wave, we will discuss in this particular chapter. Okay, so first of all, what is that, what is sound, what is the definition of sound, first we will discuss. Okay, so a wave is a, what is a wave, what is a wave, what is the definition of a wave? Okay, so wave is a disturbance in the medium due to the repeated periodic motion. Okay, and the particle about their mean position, so that the disturbance is handed over the one particle to other without actual, without the actual motion of the medium. Okay, if the sound wave, sound is also type of wave, so it is the moving in the medium, that like this, that means if it is the moving the, is the transverse motion of the particular sound wave. Okay, and if the sound wave is moving from the one particular place to another place, this is the type of one type of movement of the particular sound wave. So that is called as the what compression and rarefaction. Rarefaction. Okay, and this is the compression. Okay, so rarefaction and this is the compression. So it is the different types of sound waves are there, and one is the longitudinal and another one is the what transverse sound wave. So what is the definition of a wave? Wave means it is a disturbance in a particular medium due to the repeated periodic motion of the particle. Okay, so then then waves have some problem. The waves can be produced in the medium. It possesses some of the properties are there in the particular wave. What are the properties are there? First property, it should be elastic in the particular nature. It should be elastic in nature. Wave means it is, it should be elastic nature. Elastic means the particle of the wave, the particle of the wave, if they are what colliding with each other, if they are colliding with each other, that means kinetic energy will be remain conserved. Kinetic energy will be remain conserved. So it is called as the elastic in nature, and so that it has a tendency to combat its original position also. Second property, it should have the high density also. So whatever the particles in the particular medium, that should be have some high density, so that the disturbance is transferred easily, and it should be free from the frictional resistance. It should be free from the frictional resistance. Yes, Kumari Akriti, why you are raising your hand?
Sir, because I have doubts, sir, in previous chapter.
Okay,
sir, can I
okay.
ask that?
So in which chapter?
Sir, Archimedes' principle of flotation.
Okay, Archimedes principle. Okay, okay. So actually in the next class, Vinay sir will take that particular class. He will clear all your doubts as well as the numerical discussion he has not completed. He will also clear all the whatever numericals are there. He will discuss the numericals as well as the doubt clearing class will take. Okay. So let me complete the
Okay, sir.
sound chapter. Actually, as the exam is nearly, so we will complete the particular sound chapter within 2-3 classes. Okay.
Okay, sir.
So next, that means wave about two types. So one is the mechanical or elastic wave, and the second one is the electromagnetic wave. One is the mechanical wave, the second one is the electromagnetic wave. Mechanical wave means it is a disturbance that travel through some material medium substance is called the medium of the particular wave, and the medium itself does not travel through a particular space. Its individual particle undergo go back and go forth, back and forth and up and down motion, so that it will be what they are in the equilibrium position. Okay, so on the basis of that, the waves can be divided into two types. One is the transverse wave, one is the longitudinal wave. Transverse wave, the question will come like, what is transverse wave? Okay, and the longitudinal wave. Okay, so what is the transverse wave? What is the definition of transverse wave? And what is the definition of longitudinal wave, and how this particular wave comes from? Okay, first comes, we will discuss about the transverse wave. Transverse wave means if the particle of the medium vibrate perpendicular to the direction of propagation, the direction of propagation, if the particle of the medium that is perpendicular, in that condition, the wave, then the wave is called as the transverse wave. Okay, that means like this, the particle of the wave will move. That means this is the two condition. If the particle of the wave starts from this particular position, it will move like this. Okay, and the topmost position that is called the crest, 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 this is called the trough, trough, trough. Okay, so this is the crest, topmost position, that is the having the maximum amplitude, this is called the crest. Okay, this is the amplitude. Okay, the distance from the mean position to the topmost, that is called the amplitude also. So this is the crest, and the topmost position, that is called the crest, and the lower position, that is called the trough. Okay, the two things are come. Crest are the elevation in the wave, the position and the maximum displacement in the positive direction, that is called as the crest. Second one is the trough. Trough means it is troughs are the diffraction in the wave or the maximum displacement in the negative negative from the mean position direction, that is called the trough. Okay, so these are the all about the crest, what is crest and what is the trough. Then there is some figures are given in the particular book in the page number 158. You just see the figure. There are different examples of transverse wave. Okay, and if you are finding out the wavelength means just I am saying that what is wavelength and what is amplitude. So wavelength means it is the distance between the two crests, that is called as the wavelength. Just making the same figure in the different. Okay, so just see that this is the distance between the two waves, two crests. So this is the distance. That particular distance is called as the wavelength. This particular distance is called as what? Wavelength. Okay, and also it is the same distance. If I just taking the distance between the two trough, also it will be have the same distance. This distance, whatever this is also the trough, or it's the distance. This is called also the wavelength. Okay. Okay, so it is the wavelength can be symbolized as lambda symbol. Okay, lambda is the wavelength of the symbol, and the SI unit of lambda is what? Meter. Okay, SI unit of wavelength is what? Meter. Okay, so this is the crest means from the mean position, to the positive direction. What is the distance from the? It is the mean from the mean position. The distance that is called as the this particular distance called the amplitude. Okay, from the maximum distance, and this is called the crest, and this is the trough, and the distance between the two crests, it is called the wavelength, or it is symbolized as lambda symbol. Okay, then yes, so uh, then this is the what and then comes to what is the longitudinal wave. These are all about the transverse wave. Okay, and then comes to what is the longitudinal wave. What is the definition of longitudinal wave? Longitudinal wave can be defined, it can be defined as if the particle of the medium vibrate parallel to the direction of propagation. If the particle of the medium vibrate parallel to the direction of propagation of the wave, then the wave is called as what? Longitudinal wave. This is particular wave is called as what? Longitudinal wave. That means the example, you can take the sound wave in the air, as well as the water waves in the particular sinking water. That means that is called as the what? Longitudinal wave. What are the sound wave that is produced in the air? If I am saying something, that means the wave, whatever the sound wave that is propagated from me, that is also type of longitudinal wave. Okay, so in the particular longitudinal wave, actually in the transverse wave, the two things are there. That one is what? Crest, one is a trough. In the particular longitudinal wave, there will be two things that is called as one is compression, and second one is the rarefaction. One is the compression, and the second one is the what? Rarefaction. So what is compression and what is the rarefaction? You see that this is the particular theoretical chapter. If you just read this particular chapter, you will understand what is the meaning of this particular paragraph, or what is compression, what is the rarefaction, you will all about. What is the compression? Just see that one figure is given, the page number 159. In that particular figure, it is given the figure of the what longitudinal wave. So compression means these are the region of the medium where the density is very high. Okay, if the density is very high in that particular medium, that particular medium is called as region is called as the compression. Okay, so distance between the two consecutive particle is less than the normal distance. Okay, so rarefaction means it is the region in the medium where the density is very low. If the density is very low, so it is called the rarefaction. Okay, that means in the figure number 159, just see that figure number C, there are some compressions are there. Just you just one spring, you just take one spring and just close with that particular spring, you will find the compression. You just expand the particular spring, you will find the rarefaction. This is a perfect example of compression and rarefaction. A sound wave, what the wave we are produced by the human being, also whatever the sound they produce for the different object, these the particular waves are also called as the longitudinal wave. Sound wave is a longitudinal wave. Then production of the sound, what is the production of sound, how the sound will be produced from the particular one source. Okay, so for the production of the sound, there are some things that will be required, some basic things that will be required. That is, first one is the time period, frequency. What is the time period? What is the frequency? Okay, so what is the time period? What is the definition of time period? Time period means it is the time taken by the what vibration to what it is the defined as the time taken by the particle to complete one vibration. Okay, that means if a particle completing some vibration, if a particle is moving and it is completing one vibration means from this position to this position, one crest to one trough. Okay, so it is completing one vibration. Whatever the time taken by the particle, that is called as the time period. It is called as what? Time period. Okay, so then comes the what is the frequency. Frequency means it is the number of oscillation what per second. Okay, so it is defined as the number of waves per second or number of oscillation per second, that is called the frequency. So time period is symbolized as T symbol. We are just symbolizing the time period as T symbol, and this say unit is second. Okay, and the frequency. What is the unit of frequency? Frequency is it is symbolized as F symbol, and its SI unit is hertz. HZ. Okay, and the full form is HERTZ. Okay, so this is the hertz. Okay, so time period. It is the time period means it is the time taken by the what vibration to complete the time taken by the particle to complete one vibration. One vibration means if the particle is moving one crest, one trough. If it is a transverse wave, if it is a transverse wave, the time taken by the particle to complete one vibration, that is called as the time period. Okay, and what is frequency? Frequency means it is the number of oscillation, number of waves per second. If you are finding out number of waves per second means if you are just taking 1 second, in 1 second how much waves can be formed, so that is called the frequency. Okay, so wavelength can be defined as the distance traveled by the wave when the particle of the medium complete one vibration. That means when the particle of the medium that will complete one vibration from this position, to this position. Okay, so this is called as the wavelength, or it is symbolized a lambda symbol. Or you can write it is the distance between the two crests, conjugative crests. So it is also called as the wavelength. It is also can be defined as the two distance between the two conjugative trough. Also, it is also called as the what wavelength. Okay, so it is the distance between the two conjugative crest or two conjugative compression or rarefaction. Also, you can call. So it is the distance between the one crest and one trough is contained, and one compression and one rarefaction is also contained in that particular what wavelength. So what is the relation? What is the relation between what velocity, wavelength, and frequency? You are knowing that what speed equal to what? Distance upon time. Distance upon time. This is called as what? The speed. Yes or no? So speed means here the we are just taking the velocity of sound wave, that will be what? Distance means this distance is called as what here? Wavelength. So we can write a wavelength upon time, is or no? So this is the velocity of the wave is equal to the wavelength upon time. Okay, so velocity of the wave can be defined as the distance traveled by the wave with respect to time taken. Okay, so v equal to, if I just mathematically you can write v equal to lambda divided by t. Lambda means this is the wavelength and time means this is the t means it is the time taken. Okay, so v is the velocity. Okay, so if the question will come like find out the velocity, if the wavelength is given as well the time period it is given, you can find out the velocity accordingly. Okay, and you are knowing that one formula is also there, that is called as the, that formula is related to the frequency and the time period, is or no? One formula is also there, that is called the frequency, in between the frequency and time period. Okay, so frequency time period means what? Frequency is what is the definition of frequency? Frequency means the number of waves or number of oscillation for a second. Okay, for a second how much oscillation will be formed, that is called the frequency. And time period means, what is the time period? Time period means it is the time taken by the one particle to complete one vibration. One vibration to complete one vibration, what is the time taken by the particle, that is called the time period, yes or no? So time period and frequency, they both are inversely proportional. If the time period will increase, then frequency will decrease. If the frequency will increase, then time period automatically it will decrease, yes or no? So frequency is inversely proportional to time period, or f equal to 1 upon t. F equal to what? 1 upon t. Frequency is equal to 1 upon time period, yes or no? So if you just increase the time period, the frequency will automatically decrease, and in place of that you can write just see that, just you can replace this particular formula, v equal to lambda upon t. Okay, so lambda upon t means the time period. So time period, in place of time period also you can write 1 by frequency, is or no? So we can write f will be goes to the numerator, so f into lambda also you can write v as a formula, v equal to f into lambda. Frequency into wavelength also you can write in place of what? Velocity. Okay, so if you anyone having any doubt, you can ask me in this particular topic. What are the topics covered? If anyone having any doubt, you can raise your hand. In this particular topic, what are the topics that are completed? Frequency, time period, what a wavelength, is or no? Then longitudinal wave, transverse wave, all the things we have, what we have discussed in this particular topic. If anyone having any doubt, you can raise your hand. Okay, no doubt. We'll go to the further. Okay, so then then we will discuss that sound. If yes, Chavi Pandey.
Hello.
Yes. Hello.
Good morning,
Chavi Pandey.
sir. Yes,
Yes.
sir. Sir,
Tell
please
me.
explain longitudinal wave once again.
Longitudinal wave.
Yes, sir.
Okay, okay. So longitudinal wave, what is the definition? Tells that longitudinal wave, it can be defined as when the particle of the medium vibrate parallel to the direction of propagation. Parallel to the direction of propagation means like this: one compression, one rarefaction is there in the particular longitudinal wave. Just see that I'm just making what is the longitudinal actually wave. Okay, if it is a particle that is moving. So here the particle and medium are compression. Here the compression are there. Then after rarefaction, that means some of the gaps are there in the particular particle. Some particles are like this. Okay, rarefaction. Okay. Then again compression. Then again compression. Again compression. Again rarefaction. Like this, the particles are moving. Okay. So whatever the sound wave that we are producing, that is also one type of longitudinal wave. In that particular condition, One rarefaction, one compression. Rarefaction means it is a type of expansion, you can say, and compression means it is a what the as the particle of the medium, as the density of the medium in the particular compression type, what will happen? The density will be very high, and in the rarefaction, the density is very low. Okay, so this is
If
the compression and
sir, if
rarefaction. Yes.
sir, I want to ask if particles are moving parallel to each other, so how waves are generated? It means how it will travel.
Particles are moving parallel. Parallel means whatever the particles are there, they are moving parallel. They are moving parallel. They are not crossing to each other. They are moving parallel. Okay. So I am just making one figure. This figure does not indicate that the particle, the total. This is the total particle. The particles are moving parallel. Okay, and they are parallel to each other. But there, that means that means the particles are likely closely some region you have seen that in that particular region the particles are closely packed to each other. Okay, that particular region is called a compression. That does not mean that the particles are not parallel. The particles are parallel to each other. This is the first particle that will move in this particular direction. This is the second particle that will move in the same direction. Okay, so it will move a straight line. So in the particular compression case, in the particular compression region, the particles are closely packed and the density is very high in this particular compression region, and the rarefaction, the density is very low.
Okay, sir.
Okay, thank
Thank
you.
you.
So these are the things we have discussed. Next chapter, next thing, that means the next class we will discuss about the how the sound needs a medium and what are the numericals we will do in the next class. Numericals as well as the speed. How can you find the speed of the particular different media and what is ultrasound? All these things in the next class. It will take 1 to 2 class or more.